And so I want to introduce Dan Abbott and Maxwell Seale, who will be presenting tonight. They will be talking about the amazing work that they and many of you have been doing in Monterey with sea urchins. And so on that note, I would like to hand it over to them and the amazing stuff that they're going to talk about.
All right. Yeah. Thank you. Thank you, Dylan. And thanks everybody for joining us. I'm super excited to have such a big turnout and to share with you some of our data and kind of the work that we've been doing. So I guess couple of Zoom things. You know, I like to keep these calls pretty informal. Obviously, there's a lot of folks on here. So you all should be muted now. And I would just say, you know, stay on mute unless something comes up, but we'll be doing questions at the very end. So got our presentations to get through. If at any point during those presentations you want to put a question in the chat, feel free to use that to kind of you know, bring stuff up and answer things, and you guys can kind of talk amongst yourselves in the chat. But other than that, I think we'll just go ahead and hop in. I'll go ahead and share my screen and start on. Wait a minute. Sorry about that. Hold on. Are you guys looking at a picture of a diver?
No, we see all your PowerPoint, Dan.
Oh, okay. That's so weird. Like when I'm doing it, I see something completely different. Okay. All right.
PowerPoint again.
How's that?
There.
We good there?
Perfect. Yeah.
All right. So yeah, so welcome. Just to kind of give you a brief overview of what we want to talk about. This day is really about kind of these kelp restoration efforts in Monterey that Reef Check has been a part of. So we're going to talk about, you know, at first I'm just going to kind of go through a little bit of background and situation on sort of what's going on with the kelp in Monterey, what the questions are and what we hope to find out, and then move on to our Lovers 3 kelp forest restoration experiment, which Maxwell is gonna take on that, and you know, talk about that subject and everything that we found out on that. And then I'll pick up the very end and talk about our 1 year results from Tankers Reef and the recreational diver effort to remove urchins from tankers. So let's start with just what happened to the kelp, or what's going on with the kelp in Monterey. I know at least most of you on this call are divers, and I'm sure, you know, as divers, we've all kind of witnessed firsthand these changes, or we've seen things that have changed. So starting with sea star wasting disease, right? It's just something we all are aware of, and you know, no one should be. This is not news to anybody that sea stars died off around 2013, and in particular, sunflower stars. There's also marine heat wave that had big impacts. So 2014, 2015, the blob, as we called it, and then also an El Nino on top of that. And then, of course, we had this purple urchin boom, this kind of big increase in purple urchins, or at least observed numbers. And this happened right around the same time that we saw the sea stars disappear. And then, of course, the big thing we're all talking about is giant kelp declines, which we've you know, again, witnessed firsthand. We've witnessed these kelp forest transitions to these urchin barren areas. So that's all kind of known and well, and you know, we all sort of agree on those things happen. But it's not always clear kind of what the cause and effects are, and what triggered what, or what, you know, what caused what. And there's still a lot of discussion and interest and disagreement on exactly like what caused this process. So let me start off with kind of, I think, the most common story, maybe the one we all started out with, which is that, we had our healthy kelp forest in Monterey. The sunflower stars, the predators of the urchins, disappeared due to that sea star wasting disease. Their prey multiplied. You had this huge increase, like that's what we saw on that graph, right? There was some warm water. Warm water's not great for kelp, nutrient poor water. And we ended up with this, right? So we ended up with urchin barrens. And I think that's kind of the story a lot of us have. And I'm not saying that story is wrong. I think there is probably truth to all that, but I think there's a lot of reasons to believe that maybe it's not as simple as that. Maybe there's a little bit more to it. For one, this timing of the urchin boom. Like if you look at this graph, it really looks like, well, look, sunflower stars plummeted, and the next day, like purple urchins just skyrocketed, right? And that makes sense. But the thing is that the urchins that we see kind of increase in 2014, when we observed them, they weren't newborn urchins. They'd been around for a couple years. We know it takes a couple years to get urchins to the size where they're observable in our counts. So those urchins that skyrocketed must have been born a couple years earlier, when those sunflower star numbers weren't super low. So that doesn't quite add up. And then the other thing about sunflower stars is that we know they eat urchins. Everybody agrees with that. But they also don't eat a lot of urchins. In fact, it's thought to takes about a day for a sunflower star to eat a single urchin. So with all that, in a year, they're just not really eating that many urchins, right? Like maybe 50 or something. And this is, there's been kind of a lot of studies that have looked into this, and some of them have the number of urchins in the sunflower star's diet as being very low. Some have it higher, but none of them have them, eating a ton of urchins. They're not warm-blooded otters who are just vacuuming them up. But we also know that urchins will avoid sunflower stars, and that there can be a behavioral response. In particular, I remember there's some studies that David Duggins did in the 80s, introducing sunflower stars to reefs that had a lot of urchins, and watching the response. And the urchins really just moved off the reef or retired to like cracks and hid. And so in his study, he really observed that the presence of sunflower stars can have like an immediate effect on kind of the number of urchins in a particular area. But if sunflower stars don't eat a lot of urchins, why did all these urchins show up, right? And it could really just be as simple, and this is particular, I think, something that Josh Smith pointed out in his dissertation, that removing sunflower stars can just have that behavioral response. And maybe they were there the whole time. Maybe they were always there, and we just never saw them because they were hidden back in cracks, so they just wanted to come on out. Now, look, it could be both of these things, right? You see a curve like this, and it could be, some of it might be behavior, and some of it recruitment or new urchins being born. It's probably a combination, and we're just not quite sure how much is which. But looking at this graph here, it does make sense that you would see this increase, directly after the decrease of sunflower stars. Okay, well, that's enough about urchins for a bit. How about giant kelp, right? So we've all seen that giant kelp has declined. And when you look at this graph here, it looks kind of like a slow decline over the years, especially the last four or 5 years. But in reality, I think what we've all witnessed isn't just like a slow thinning of kelp throughout the Monterey area, but we've seen some sites go to, urchin barrens, as early as like 2015, another kind of set of sites, after that. And there's some sites that through this whole time, through this whole loss of sunflower stars and huge increase in urchins, there's still have a lot of kelp and are, relatively in that normal range. And actually, if you think about it, like as I was going through trying to categorize different sites as barrens or forests, it was actually a lot more difficult than you think, because in Monterey, even the most barren sites like Coral Street or South Monastery still have patches of pretty healthy kelp, whereas even the areas that have a lot of kelp that you think of being very robust and healthy still have areas that are complete urchin. So it's a real patchwork. It's a real mosaic. And I'm going to show you a video of what that looks like. So here you can see a pretty healthy kelp forest. And then right on the edge, it just a real abrupt change. Just complete urchin barren. And I would say this kind of interaction is fairly common. Even in places like South Monastery, there's very dramatic barren right next to a pretty healthy kelp patch that has been there for multiple years. And you think that it's going to be gone tomorrow because there's so many urchins right next to so much kelp, but sometimes they can persist for years. The other thing that we've seen is an increase in bull kelp, in particular out on the outer peninsula, where areas used to be completely giant kelp dominated, became barrens for a couple of years, and now are dominated by bull kelp and are no longer urchin barrens. Pescadero is a site that kind of made that transition this year. So let's revisit our story, or tell like another story. So in this one, same thing happened at first. The predators disappeared. We definitely had this marine heat wave that caused some poor kelp years. So we had some kelp disappear. And in this one, the urchins switched to an active feeding behavior. So they, due to the lack of predators and due to the lack of food or drift algae that they could eat from their homes, they switched to an active behavior, came out of their crevices and started moving around on the reef. And we ended up with this. We ended up with a lot of barren areas, and we ended up with some patches of kelp that are still here. So that's all great. And regardless of exactly what factor led to what and how much of it is recruitment and how much of it is behavior, the question becomes, can we restore kelp? And that's something that I think all of us are pretty interested in and motivated to figure out. And it's a big question, right? So one thing that we need to know is like, well, can we go out there and remove urchins? And if we do that, will kelp return? And if so, how many urchins do we have to remove? How low do we need to get these urchin densities? And is it possible for, say, recreational divers to achieve those low densities? So those are all kind of questions that we need to figure out. Fortunately, there's been some recent studies on the West Coast that has kind of pointed in the direction that these things are possible. So Southern California, Palos Verde, there's a study by the Bay Foundation where they were planning on culling a bunch of areas and seeing what the kelp response was. And they got a couple years in, and what happened was there was an urchin disease that took over and lowered the density at all their sites, both the treatment and the control sites, to around 2 per square meter. So big reduction from about 18 per square meter to 2 per square meter. And just to give you a heads up, we're going to be talking a lot in this presentation about urchin density, and that 2 per square meter is going to be coming back up. So once they saw that, kelp did return to those areas in about 6 months, and once it returned, it stayed. Another recent study was up in British Columbia, up in Haida Gwaii, done by the Haida First Nation. And here, urchins were either fished out or culled, depending on if they were healthy or not. And they reduced urchin densities from about 5 per square meter to 0.6 per square meter, so pretty low. And here, they similarly saw a dramatic increase in kelp, this time bull kelp, where the density went from about 8 per 60 square meters or per transect to 56. So a big increase there. But what about Monterey, right? So Monterey is a different ecosystem. We don't have sheephead and we don't have lobsters like Palos Verde. We do have otters, which is good. We're dealing with mainly giant kelp and bull kelp too. But it is a different ecosystem than these other 2 areas. And so we were interested in figuring out if kelp restoration would work in Monterey. And with that, I'm going to turn it over to Maxwell Seale to talk about our 3 years at Lovers.
All right, give me just a moment. Stop sharing screens.
While you're doing that, Maxwell, I wanted to remind folks, if you ever have any questions, feel free to ask them in the chat, and I'll sort of organize the Q&A session for after the talk so we can get all your questions answered for you.
Cool. All right, can you see my slide? Sweet, fantastic. All right, thank you, Dan. Now let's go ahead and transition into discussing the first attempts at kelp forest restoration in the Monterey Bay National Marine Sanctuary. Let's see here, give me just a minute. Perfect. Our work at Lovers 3, encompasses 3 years of restoration efforts, which is a lot of information to digest. So if you get lost during the presentation, feel free to refer to the slider at the bottom of each slide to reorient yourself. We will cover the experimental methods, results, and key lessons learned from each year in order. In addition, I will be using a set of helpful icons when I refer to different species represented in each graph today. We'll be referring to 2 distinct species of urchins that compose urchin barrens in the Central Coast, namely purple and red urchins, depicted as small purple and large red icons respectively. And to simplify our kelp results, I'll use an icon with a kelp here to represent all kelp species. Though we do observe both giant kelp and bull kelp during the restoration process, we assume each is equally likely to return or recruit under the right conditions. All right, so from this point, we spend the next 3 years attempting to figure out what exactly those conditions are. More specifically, we use this time to sort of posit 2 fundamental questions. First, what urchin density allows kelp to return? And second, can volunteer divers reduce urchin densities to specific densities to restore kelp? I'll refer to this density as a threshold density. As Dan mentioned, research by both in Palos Verdes and in Haida Gwaii indicate that this number is sort of in contention. So we say 2 urchins per square meter in Southern California, and we sort of like use this as a proxy for the rest of our presentation. But again, of course, because the 2 systems are different, we want to test the threshold density assumptions here to help inform research managers and restoration practitioners in our region. To identify the Monterey Bay urchin density threshold, we devised an experiment to reduce purple urchin densities to specific treatment levels or densities and monitor kelp response. Here we show purple urchin density on the y-axis in urchins per square meter. And along the x-axis is just the number plot or location undergoing the specific treatment. During treatment, teams of volunteer divers use hammers to cull urchins down to 8 different treatment levels across 16 total plots every 3 weeks. That's 2 plots per treatment. Changes in urchins and kelp were measured on 4 control plots where no work was done in order to compare environmental effects separately from restoration efforts. Because purple urchins generally far outnumber red urchins in the Central Coast in most cases, we only initially reduce purple urchin densities and leave red urchins in place. This is under the assumption that they would pose no significant threat to kelps. And the photo here depicts what a plot typically looks like, surrounded on all sides by sand and sand dollar beds, theoretically functioning as an isolated system from the surrounding barrens. Now, before I show you results from all of our plots, here's an example of what one plot is. This is sort of like the behavior of what we saw happen on a plot with respect to the density of urchins during restoration. Again, we have urchin density plotted on the y-axis and time in weeks along the x-axis. Initially, divers will cull urchins down to the red line, which is the treatment level. Then after returning, divers will find urchins have recovered to the turquoise dots and culling is repeated. For our analysis, we use a sequence of advanced models to understand how urchins repopulate treated plots after each cull. So we are analyzing essentially those dots themselves. Most importantly, before I sort of go on, we found that restoration plots are not actually isolated systems. Rather, urchins will quickly repopulate reefs by crossing over sandy bottom in just a few weeks after culling. So first we can ask, can purple urchin treatments be maintained? And sadly, the answer is no, at least for the first year. This is essentially the same graph as previous, but now we include all treatment levels and plot a red line at 2 urchins per square meter for reference. Here we find the treatments below 5 urchins per square meter to produce essentially the same results. That is, purple urchin densities are on average challenging to maintain below about 3 urchins per square meter as urchins quickly repopulate plots after culling. Now, what about red urchins? This is actually another unexpected finding. This year, we actually observed red urchins increase over the entirety of the site, regardless of treatment. Here we see red urchins exceed a density of 2 urchins per square meter on several plots. And though there's no significant difference in time relative to the control plots, this still puts the total number of urchins on a number of plots over our theoretical threshold. Separately, though we do see a number of kelp recruits on some of our plots, recruitment is not significant enough to define an urchin density threshold. Kelps that do recruit also see low survivorship over the course of a given season. So at the end of our first year, we find that purple urchin treatment densities cannot be maintained as readily as urchins readily cross over the sandy bottom to forage for food. In addition, we observe red urchin densities increase on control and treatment plots across the site. And we find that red urchins approaching or exceeding 2 urchins per square meter in many cases, which puts the total number of urchins well over our theoretical threshold. Surprisingly, we do see some evidence of kelp recruitment, but there's no significant survivorship, and recruitment is not ubiquitous amongst all low density plots. And this is something to be expected given the aforementioned urchin densities. And separately, due to the time we received permit approval, we had not begun the restoration process until the summer. So it's possible that we may have missed a key kelp recruitment window during the spring upwelling season. So we can use this information to sort of adapt and repeat our experiment with a hope to maximize kelp recruitment and survival. In year 2, we opt to call all observed urchins to 0 and keep the treatment levels for purple urchins as the same treatment levels for purple urchins as the previous year. Again, we conduct culls approximately every 3 weeks. Interestingly, we find that urchin densities on treated plots do not recover fully over the summer season when no culling work is done. Here, urchins from low density plots remained low relative to controls, but still increased over the off season. Though if in the first year plots urchin densities were not significantly different from the controls, again, the relationship remains true. They're not significant when we observe them at the beginning of the following season, and we call these treatments essentially ineffective. We can repeat our analysis and include the total density of purple urchins and red urchins in our model. So in year 2, we continue to see a constant influx of urchins throughout our treatment plots. On average, all low density treatment levels remain at approximately 1.9 urchins per square meter and do not differ significantly from each other. The idea to keep in mind here is that though this is lower than our theoretical thresholds, it's still higher than most treatment densities. Weak recruitment was observed in year 2 on some low density plots again, but not all, with some survivorship, more so than year 1. However, we find no significant difference in urchin densities where kelp was and was not observed. Thus, we've not yet determined a specific threshold density quite yet. So in summary, urchin densities at low density treatment plots technically fall below our theoretical thresholds, but it's difficult to maintain urchins below 2 urchins per square meter. After 2 years of treatments, some kelp recruitment was observed on some plots, again, but not all. So thus, low densities of urchins do not guarantee kelp survivorship, as survivorship is poor. Thus, we do not have sufficient data to determine that threshold. And then in addition to this, it's worth mentioning that also, as well as a number of other scientific institutions, a number of our field operations were put on hold in 2020 because of COVID, of course, forcing us to start restoration work in the summer again, rather than in the spring. In year 3, we decided to shift our focus from controlling the number of urchins themselves on plots, and instead focus on controlling for effort. By doing so, we use effort as a proxy for determining threshold density. To test this, we compare culling on a weekly basis versus a monthly basis to determine if urchins can be capped at low enough to ensure kelp survival. And we think that leaving urchins behind may have left kelp recruits vulnerable to grazing, resulting in low survivorship where kelp recruited on low density plots. So for year 3, we opt to cull all observed urchins and keep the densities as low as possible. Separately, we use this year to begin culling in the spring and compare those results from starting in the summer. So here we test to see if the majority of recruitment was observed only in the spring, or if we see like ubiquitous recruitment all year round. This gives us 4 brand new treatments where all previous treatment levels were evenly distributed at both high and low densities to control for the impact from previous years. Here's just a table showing the 4 treatment combinations: spring weekly, summer monthly, and so on. The culling frequency should give us 2 densities to determine our urchin density threshold where kelp survives best, regardless of season. And separately, start date should help us tease out the seasonal effect on kelp recruitment itself. Now that we are comparing sort of low densities of urchins relative to the surrounding barrens, we wanted to ensure that our estimates were not skewed from any initial errors in measuring the plot's surface areas. We use surface area of a plot to estimate urchin density, and small variations in this measurement makes comparing densities between plots especially challenging. Thus, to ensure the density estimates are directly comparable and are at resolutions that are biologically relevant, we employ photogrammetric techniques. And to do so, we use a camera to scan the seafloor and collect hundreds of photos of each plot. These are used to build 3D models for each plot to obtain a high resolution surface area measurements. And we can double back and use those measurements to calculate densities and build more robust models for all 3 years. Now, when considering culling effort, we find that weekly culling yields significantly lower urchin densities than monthly culling. When we use culling frequency as a proxy, we find that weekly culling results in average urchin densities of 0.2 urchins per square meter compared to the 1.1 urchins per square meter average for monthly effort. We use a special model that accounts for the variation introduced by effort from the previous years, and the relationship holds true. Weekly effort is still maintains urchin densities far below monthly effort. So can we finally answer this question? At what density do we see kelp recruit and survive? Well, before beginning culls, kelp recruits were found to have recruited on just over half the plots. These plots had urchin densities at about 2.3 urchins per square meter. And we find that the density of urchins where kelp was present is significantly lower than those where it was absent, though there's lots of variation that exists where kelp was absent. Separately, we can see how kelp responds to these different efforts through time, depending on the season. So in the spring, we can model survivorship by taking kelps that survived long enough to grow 1 meter in height and count all of their stipes. And here we see that stipe counts increase through time on weekly plots, but poor kelp recruit survivorship on monthly plots and on controls, where we did even see kelp recruits. After 22 weeks, we see on average, our stipe counts increase to 36 stipes per 60 square meters or per transect for our reef checkers. And in addition, a number of bull kelp recruits reached sexual maturity by the end of the season, which is pretty cool. As far as our summer plots go, it's a slightly different question that we have to tease out. So because we've not really given the summer recruits enough time or sufficient time to grow 1 meter in height, we do see kelp recruitment though on these plots. Instead, we opt to model all recruits of all sizes. Overall, recruitment was observed on all plots, but the highest was on the weekly plots as well as survivorship. Though there was lots of variation in survivorship, any recruit at all was essentially a bit of a surprise. However, one weekly plot did see an overwhelm of urchins between treatments, which caused significant losses in kelp over a very short period of time. This sort of serves as a reminder that young recruits are especially sensitive in their early life stages. As we come to the end of this segment, I'd like to show you a comparison of one of our successful plots before and after 3 years of restoration work. It's been a pretty magical experience watching all of these kelps grow over the course of the year. And in particular, I'd like to think that it's just a sort of really jarring, surprising image to see overall. So after our 3rd year, what did we learn? Have we identified an urchin density threshold below which kelp can survive? This is a complex question where technically kelp recruitment was observed on plots approximately 2 urchins per square meter, but in most cases did not survive. And instead, kelps may require a density 0.2 urchins per square meter to be kept alive, at least in the Monterey Bay system. This is an order of magnitude lower and challenging to achieve without weekly effort. We do see kelp recruit to restoration plots regardless of season over multiple years, but note that young recruits are highly vulnerable to overgrazing when left unattended. Moreover, survivorship to sexual maturity requires a spring start to allow kelps enough time to grow, whereas summer recruits may not have enough time to reach sexual maturity after culling support ends in the winter. All right, now onto some closing remarks before I hand things off to Dan. Let's revisit our fundamental questions. First, can volunteer divers restore kelp? Kelp restoration requires a concerted effort. Maintaining low densities of urchins demands focused attention to prevent restoration areas from being overrun. Diffuse effort on a monthly basis is not effective at ensuring kelp survivorship. Evidence indicates some carryover effect of effort between years when restoration persists, and restoration may be feasible with volunteer effort. But it will require constant involvement, possibly over multiple years. Moreover, to put the restored kelp into perspective, we observed an average of 36 sites per 60 square meters or per transect, where the local historic baseline averages at 150 sites per square meter or per transect, which is pre-2013. Separately, what density of urchins allows kelp to return? Urchin densities observed here challenge our initial assumption that 2 urchins per square meter as a threshold remains true in the Monterey Bay system. This metric is commonly used in determining project success when implementing restoration efforts. However, to ensure kelp survival, evidence from our project indicates that the threshold is an order of magnitude lower than previously assumed, at least for the Monterey Bay system. With this information, we can recommend restoration practitioners and resource managers attempting to restore a kelp forest to consider the following. We suggest aiming to reduce urchin densities to below 0.2 urchins per square meter. We highly encourage weekly efforts and visits to restoration sites to ensure densities are maintained at a low level. And we recommend beginning restoration work in the early spring to allow kelp to reach sexual maturity and maximize kelp recruitment. And with that, I'd like to thank all of our contributors and our volunteers for making this work possible. It sure takes a village to raise kelp, for sure. I'd like to thank Dan Valentine for producing our 3D models and Emma Barton for helping keep our kelps alive at in the previous season. But most importantly, I'd like to send a special thanks to Keith Rutzart for leading this project for its first 2 years of its inception. And with that, I'll hand things back off to Dan.
All right, thanks, Maxwell. That was great. Cool. I'm just gonna pick up right there, and we're just gonna go to our last section. This one will go fairly quick. But yeah, so first of all, speaking of this guy, he used to volunteer for me, and now my job consists of following him around, counting how many urchins he's smashing every year. But yeah, so Keith really was the driving force behind that experiment to see if kelp restoration was possible. And now he's moved on to Tanker's Reef, and he's spearheaded an effort there. Whereas the Lovers project was really an experiment looking at restoration with very small plots, like we're talking, I mean, you saw pictures of them, right? Like 40 square meters. Tanker's Reef is a large area. So it's really a project. It's not an experiment anymore. It's a project to restore kelp that Keith is leading the charge. He's built an army of urchinators that are going out there and getting this work done. And our part in it, Reef Check's part, is really just to run around behind him and quantify the results. So that's what I'm going to do in the next, say, 10 minutes, is just talk about the results from year one. So first of all, just a bit about the project area. It's kind of a large area off of Del Monte Beach. It's a recreational fishing rule change. So anyone with a recreational fishing license can go out there and smash urchins. For our project, so even though this whole project area boundary, we have two areas that we are focused on. So one is the treatment area, also called the grid, where divers are kind of focusing a lot of their effort. And we have a control area, which is kind of off down the beach where we're hoping folks don't go. It's kind of out of the way, where we can compare the results. As far as the grid goes, so this is an actual grid that's installed down on the bottom, 100 meters by 100 meters. There's lines, there's 10 lanes that are 10 meters wide. And so recreational divers are given an assignment. Keith gives them like a lane to go down, and they clear as much of that lane as they can before moving on into the next one. And the whole thing is about 2.5 acres, 1 hectare, about 2 football fields. So this got started this year, or sorry, last year now, 2021. So we installed the grid in March of 2021. The rule change went into effect shortly afterwards, and culling began mid-April. It took a little while, about a couple months, for the first 2 lanes to be completed, for the divers to get in there and work and clear all the urchins out of those 2 lanes. So like into summer. And then things moved pretty quickly. July 13th, the next 4 lanes were cleared, and the final clearing was done in September 8th. And of course, the divers weren't just going in there once for the most part. Once lane lane A was cleared and they were on to lane D, at some point they'd go back and work in lane A again to keep the whole thing clear. And of course, surveys were done at the beginning, before the clearing, and then afterwards in the fall to compare the results. Now, I just made this sound pretty simple, right? It's just a bunch of, it's a box on a screen where people cleared, but it was a tremendous amount of effort, a huge effort of volunteer divers. Over 80 divers were involved in the project. Keith had a whole training program that folks went through. I know a lot of you are like Reef Check divers, went through like an online training that I put folks through. 386 underwater hours, over 200,000 urchin smashed. And that's the whole project. And I just want to point out that only a little bit less than half of that was focused on the grid, and a lot of the other effort was sort of in the surrounding area. So that's kind of what happened. So how about our questions, right? So the first project question was, can divers reduce urchin density? And when this project was set up at the beginning of the year, we were really focused on that 2 urchins per square meter threshold. And so that was kind of, the metric that Keith was trying to hit. And so the good news is the answer is a pretty solid yes. So in the grid, total urchin density, purples and reds, went from about 7.1 to 1.1. So a pretty significant decrease. In the control area, there wasn't really a significant change. It was, right in that 5 to 6 range. So that's pretty awesome. Those of you who have dove Tanker's Reef know that the area, there's a lot of sand, right? And so there's a lot of rock, but a lot of the area is sand. And so one thing that we were interested in is like, well, okay, so if you got the total density down to 1 urchin per area, but that area includes rock and sand, what is the density just on the reef, right? Because kelp doesn't grow in sand. Urchins don't they might cross sand, but they're not really hanging out there. So if you take into account that not the entire area is suitable reef, but instead just work off the percent of actual reef, how does that change the densities? And are the divers still getting those densities below that important 2 per square meter threshold? And once again, the answer is yes. So when you take into account all that sand, the density on reef in tankers in the grid went from 9 to 1.4. So still a really, really big increase. And in the control, we're still not seeing that significant of a change. All right, and then next, how quickly will urchins repopulate the grid, right? When we set up the Lovers 3 experiment, we didn't think they would cross sand, and they did, and it made it really hard for us to maintain low densities, right? So tankers is more or less continuous reef with a lot of sand patches, but we were very worried, or at least I was, that like urchins would kind of flood back in, and you'd clear out a whole bunch one day, and the next day you'd go back and they'd be the same. So one of the things that we did was in lanes A and B, after they cleared them, there was a month where no divers went in there and culled urchins, and then we went back a month later and saw what the change was. And fortunately, there was very little change. So after a month of no culling, we did 4 transects, and so these are the results of those 4. There was essentially no difference in the density. I should note that, remember, only 44% of the effort was inside of the grid. So even though divers weren't clearing in those lanes during this time period, they were clearing kind of on the outside of the grid, and so that may have had an effect. But still, the important thing is we didn't see urchins just kind of flooding back in. They didn't seem to be moving that much. All right, well, that's great. Urchins, right? Urchins. But like what we really care about is kelp. So what happened to the kelp? And I think for this project, we didn't really see a big change in the first year, but I wouldn't read too much into that. I really think it's a little bit too early for a couple of reasons. So one is that, remember, they didn't finish clearing the grid until beginning of September. And so that's basically the entire year, right? And you wouldn't expect them to finish one day and there to be kelp everywhere the following day. So it definitely takes a little while. And then, of course, the other thing is that we didn't survey until the end of October, which is like pretty late in the year in terms of like kelp, just the normal seasonal pattern of kelp anyways. One of the reasons we weren't able to survey earlier was because of a bunch of big storms. So anyways, all those things can have a big effect. So I wouldn't read too much into the fact that there wasn't a huge response in kelp this year. Hopefully they can keep it fairly maintained over the winter, and we'll see a stronger impulse next year. All right, so just real quick, wrapping up lessons from year ones. Recreational divers can definitely reduce urchins to less than 2 urchins per square meter. They don't seem to repopulate the cleared areas very quickly. And we didn't see a whole lot of kelp regrowth. That might have just been due to the timing. It might be because the density, as low as they got it, wasn't low enough. And it can also just be because of environmental factors, right? All we can really do at the site is remove urchins, but there's a lot of factors that go into determining whether kelps grow or not. There was some pretty warm water that was on the site, about over 60 degrees Fahrenheit. That was on the site over the summer. I'm not saying that had an effect, but it's just this restoration work. All you're really doing is clearing away for kelp. You're just giving kelp the opportunity to grow, but you can't always make it do what you want. Okay, well, with that, I just want to thank in particular everybody who's helped out with both of these projects. Definitely all the Reef Check volunteers who have been monitoring kelp on the coast of California for 13 years now, who have put many hours into that lovers experiment, both in removing urchins and in monitoring the results. Going out at Tanker's Reef and doing a whole bunch of work out there, counting all the urchins, not sub-sampling, and of course all of them and all the other divers who devoted their time and effort to going out there and clearing urchins from the Tanker's Reef project. So just huge thanks. It's just always so inspiring to see so many people that are willing to devote their time and effort into this issue that we all care so much about. So huge thank you to all of them. And with that, I think we're ready for questions.
Yeah, awesome job, Dan and Maxwell. That was incredible. And so we do have a fantastic list of questions that I'm excited to hear what you guys have to say about. So to start off, Kevin was wondering basically how the active versus passive feeding of urchins might impact our ability to survey them accurately, and what your guys' feelings about that might be.
Yeah, no, that is a really great question, and I think that's back at the beginning when I showed that chart of purple urchin population just skyrocketing. I think the point that I was trying to make is like that might not be an increase in population at all. That might merely be an observational change where we didn't see them because they were like way back in cracks and crevices, and then they came out and we witnessed them all. So I think you're definitely onto something there, Kevin.
Yeah, and then also Francisco was interested in maybe how urchins might be able to detect if there are predators around, and then also if they'd ever maybe be able to detect you guys there to be able to cull them.
Right. So definitely urchins are able to pick up on chemical cues from Pycnopodia, from sunflower stars, and so that's how they know that they're there, and they've done experiments where they like basically run water over sunflower stars and into urchins or different directions to see, and they've shown that the urchins will move away from them, in particular small purple urchins. As far as like us, I'm afraid I don't think we give off those chemical cues, and then the urchins aren't, they're not evolving that fast where they can learn a new skill like that. So yeah.
Or at the very least move fast enough, right?
Right. Yeah. And they can't move fast enough. Yeah. We can smash more than one urchin per day. Yeah.
And then a question that lots of people asked about was the potential, like the possibility of gamete release. Is as we're going down there and we're smashing them, are we just making the problem worse by releasing a bunch of urchin gametes?
Sure. Maxwell, do you want to take that one?
Dan, you want to? No.
Yeah,
so first and foremost, it's challenging to say in a field setting whether or not we do see kelp urchins spawning or artificial spawning from this work. At the very least, at Lover's Point, the work was done on a really small scale, and we're actually deploying settlement plates, or we were collaborating with collaborators that are planning on deploying settlement plates at Tanker's Reef to see if we're seeing any significant spikes in urchin recruitment. We do sort of think that the urchins are around and they're gonna breed anyway over the course of the winters when their breeding season is. And usually they'll cluster and synchronize all their gamete release all in one go to maximize recruitment. So what we would do, or what any restoration practitioner would do in the field, wouldn't be any better necessarily than what they're planning to do in the wintertime anyway. So one explanation. Dan, I don't know if you wanted to add to that.
No, I think, yeah, I was basically going to say the thing. It wasn't something that we specifically looked at. I know there was a lot of concern about it. But yeah, I've not seen evidence. Yeah.
Cool. Awesome. And then did you all observe any reemergence of the predators coming back to your reef who might be eating the urchins, whether it's the sunflower star or other things? And particularly like maybe otters as well.
It's a really funny answer, actually, that at least we saw. I mean, I think we've seen it both projects now. Like after culling over the course of a number of either months or even years, the fish in the area actually sort of pick up on when people start to cull urchins. And they almost immediately start feeding on the gametes that are left behind. So, you know, we just sort of leave the urchins in the fields, and nature sort of does the job of cleaning up those gametes pretty quickly. So at the very least, it's not necessarily like a natural predator response, but I mean, it's pretty vicious how like a very small like pack of sand dabs will tear apart urchin gametes pretty quickly. As far as sunflower stars, we're still not seeing sunflower stars in the Central Coast. You know, they're red listed on the IUCN critically endangered species list and so forth. Dan, if you want to.
Yeah, definitely no sunflower stars, and I think as far as otters, definitely not something that we witnessed. I think it's been shown pretty clearly by Josh Smith in particular that otters do not, you know, really feed on urchins that are in barrens that are in a semi-starved state, but they do feed on urchins that are in kelp forests. So, you know, in theory, I think if you could restore an area and the urchins were healthy, then you would get otters feeding on them. But yeah, I don't think we got anywhere near that point.
Cool. So we have lots and lots of questions. I'd love for the opportunity to like let folks ask them themselves, but I'm gonna try and get everyone's questions answered. So one thing that folks were curious about is you were talking about maybe the sexual maturity of the kelp that you were encountering, and how exactly did you know if a kelp individual was sexually mature or not?
That's cool. It's actually pretty easy. When you're looking at bull kelp, the blades on the top of the bull kelps will produce sort of like these rectangles that are called sori. And when those sori senesce, it's essentially their sort of little babies that will propagate from there. So at the end of our culling season in year 3, we saw tons and tons of bull kelp with all that had tons of sori that were sort of sloughing off and sort of very typical from a sexually mature bull kelp.
Cool.
Yeah.
Awesome. Let's see. There were a lot of questions about folks that were really intrigued about the urchins crossing the sand. And so first, what sort of prompted you all to assume that they would not go across the sand? And then additionally, is it possible that this could be like an explanation for the quick recovery in urchin populations that you guys saw on your plots?
Dan?
Yeah, I mean, I just think we thought for the most part they didn't. Like when you're out there diving, you don't see urchins in sand very often. I mean, now that I'm focused on this, I do see it, you know, not infrequently. But you know, you just don't think of urchins crossing sand. They not very hydrodynamic. They have a hard time. But clearly they do. And what was the second part?
The other thing was, could urchins from one plot cross the sand into another?
Yeah, for sure. And these plots were far away from each other for the most part. They weren't necessarily always far away from other reef. And that's definitely one thing that we noticed was that proximity to other reef definitely had an impact on how fast they would return. But yeah, I mean, I think it's very interesting in particular that it's complicated this experiment so much because we really set out to have these isolated plots, and it was going to be this whole thing where we could maintain these exacting densities because, urchins wouldn't move. And movement became a huge thing, and we haven't really seen that. We didn't really see that at tankers. There is movement, but it's not this huge movement. And I know up in Noyo at our restoration site up there too, there hasn't been a huge migration. So yeah, it's definitely a interesting thing.
Sweet, yeah. And something that other folks were interested in, they were curious if you did any apart from density, what other measurements did you guys take? Did you do size, frequency, gonad mass? What did you guys?
Yeah, we definitely did a size frequency. So we have a lot of size frequency data. We also take size frequency data at just a lot of our reef check surveys. So we have a ton of that. And we do a gonad index, kind of a scoring on a 4-point scale if they're starved or have some gonads, or all the way up to healthy. And pretty much all the urchins that we saw were either a 0 or a 1, like starved or like very, very little.
Very cool. And so this kind of circles back about, I should have asked this last time, but we were talking about kind of having the plots isolated a little bit. How do you think that might have either helped or hindered this research? And then also, where do you think the closest kelp forest that could release kelp gametes to where they can then recolonize the forest as well?
Maxwell?
Let's start with the first part. So you were saying how, so as Dan had mentioned, sort of the proximity to the nearest reef definitely impacts overall how quickly urchins can repopulate a location. We have, and I sort of observed this in the field, and I'm sure Keith did as well. When you put a restoration plot right next to a control plot, you sort of watch the urchins just travel very quickly when they're really almost kissing. And you just sort of come back and you see a ton of urchins right afterwards. But when there are also some a ton of plots that are super far off in the sand in the middle of nowhere. And really the urchins that you see are, even if there are any, are ones that you missed from the previous go. They're really small. They were hiding somewhere on the top of the plot if it was a really tall plot, say. So I would say that if you could control for the distance of plots to proximal reefs, that would be another great research question. It's so challenging to be able to make that kind of control. So, we do the best we can. We get as many replicates as we can when possible. And then in addition to that, sort of proximity to kelp is an interesting question as far as restoration goes. On the one hand, sure, you definitely want to cull closer to a kelp forest than not. Sort of assuming that you get a benefit, an added benefit from the kelp forest being able to regenerate itself. And this is research done from a number of people talking about the synergies of how kelp forests remain stable and how urchin barrens remain stable. But there is also research to indicate that kelps may endure for long periods of time in urchin barrens as sort of propagules waiting for the right conditions to start springing up again. So it's a complex question to sort of tease out. Ecology is really complicated.
Yeah.
So definitely the subject of future research for sure.
Awesome. And so Josh Smith had a couple questions for you guys. The first one being, there are several places in Central and Northern California where bull kelp is recovering, but also urchin densities are high and even unchanged. He wanted to know if you guys had any thoughts about what might be happening here ecologically.
Yeah, sure. That's definitely an interesting question. And welcome to the call, Josh. Yeah, so I should start off by saying that I'm definitely less familiar with Sonoma and Mendocino, although I did grow up diving there and dive there every year. What I have seen is the kelp that has appeared up there has really been driven by substrate. And in particular, like you'll see like small boulders surrounded by sand, and the bull kelp will grow on that, or you'll see pinnacles, things of that nature. It's almost like bull kelp's just growing where it can. But that said, I don't have a ton of experience up there. I know there's been a lot of talk of a kind of a recovery up in Mendocino and Sonoma. I do feel that talk is a little overblown. I think we're seeing, there's kind of a natural variation that happens every year. And kelp used to go from like, 80 to 120% of some average. And now, we were at 5% of that average, and we're going from 5 to 10. And maybe it'll keep going up. Like, that would be pretty cool if it's a recovery. But I guess my prior would be that it's just going to keep going in that kind of smaller range. And I haven't seen anything personally up there that is a dramatic decrease. I'm sorry, dramatic increase. The sites that I dive in Sonoma in particular, they don't look any different.
Cool. Yeah. And then for his second question, he asked if you think that there's a behavioral threshold or like a proportion of urchin that are exposed that may be different from the density threshold, and how that might be important in kelp restoration efforts.
Yeah, for sure. Yeah, it's an interesting question too, because like when you're at tankers, a lot of the areas there are like at tankers, there are areas that are normal barrens with all the urchins exposed, and there are other areas where the urchins are back in cracks, back in holes. Maybe there's fewer out there. So yeah, it is interesting. I don't know what that threshold would be, but that would be a really interesting thing to look at, like percent of, or like number of exposed urchins per square meter.
Cool. Yeah. And then one other question that a few folks were really curious about was if we had any data on what these sites, what urchin densities and kelp densities at this site were like before they became barrens. Are those data available? And if so, what did it kind of look like?
Yeah, so in the Monterey area, we definitely have, so we started doing our surveys in 2006. So we have surveys from a bunch of sites in Monterey from 2006 to 2013, and kind of the pre sea star wasting marine heat wave world. And over that time period, the urchin densities were very low, like less than 5 per transect. So like
Very low.
very low, like 0.1 or less.
Those were the days.
yeah. And again, I do think there's probably an observational component to that, but nonetheless, they were very, very low. Whereas kelp densities were in that, say 150 to 200 stipes per transect range. And now, many of these sites have 0 or very, very low numbers.
Yeah, those are very different than what they were.
Yeah. Night and day.
Yeah. And then I wanted to circle back really quickly about a question we had a little bit ago, talking about the sexual maturity of the different kelps. I think that they were actually referring to giant kelp, in that they were curious if it had spore fills or not, or if we were just basing it off of 1 meter in height.
Yeah, no, specifically just the basis for the survivorship was just a meter. It's just sort of an arbitrary line in the sand. But if I remember correctly, there might have been a few recruits that may have had some sporophylls sort of at the base, sort of developing at the beginning or at the end of the season. I can't remember for specifically off the top of my head. It wasn't something that we were paying too close attention to.
Yeah, cool. That makes sense. And so there are a few questions here. Just do a couple more, and then we can open this up for you all whenever you guys would, in the audience, if you wanted to ask questions too. So we'll do a couple more. The first one is Barbara is curious about what sort of efforts might extend beyond Tanker's Reef? Where exactly are we looking to scale this up to?
Well, like I said, I just follow Keith around, so I think that's kind of a question for him. I know he's itching to expand this to sites all over the Monterey Peninsula, or I guess I should say in all of the conservation areas. So I think that you would have to talk to him for that. I think for us, we're really trying to quantify the research and kind of give managers the information that they have so that they can make like the best possible decisions.
Yeah, definitely. And then one of the last ones is for folks, not everyone on this call has been involved with us at Reef Check before, and they were curious what typically what do they have to do to start working with us, and are there any sort of prerequisites for them?
Oh, excellent question. Yeah, for sure. So we do classes every year. You got to be a certified scuba diver. We want you to have at least 30 dives, 15 of which should be kind of in this area in the Central Coast or wherever you're doing your training. And then that's it. Our classes are limited. So if it's something that you're interested in, definitely sign up. And know that for the Reef Check class, what you're being taught is kelp forest monitoring. So you're being taught how to like measure the health. We teach you, transects, fish ID, invertebrate ID. Definitely check out our website, just reefcheck.org, and you'll see all that information. We're actually going to be posting our training schedule soon, probably within the next week. But also know that you can get involved if you just want to get involved in tankers and go out there with hammers and smash urchins. I would suggest going over to the G2KR website and registering with those guys, and they can hook you up with one of their training classes.
Awesome. Yeah, I'm really excited to see how we can keep including the community in this project. It's going to be great. Cool. So that's pretty much, there are a few other like sort of niche questions that I think we might touch on a little bit if those people wanted to wait. But if anyone else has just sort of lingering questions, feel free to jump in here. We want to hear what your thoughts are. Well, cool. If no one has any more, I guess we can do these last three questions. And so
Perfect.
The first one comes from Tim Clear and Maxwell. He was really curious. You talked about a special model to account for urchin densities from the previous year. He would love to hear more about this and asked, we asked if it was a Cox regression or what exactly it is that you did.
Here we are. This is where everyone falls asleep. So we use something called the linear mixed effects regression. And we use treatment as a random effect in order to say, like, sort of separate from the fixed effects that we're seeing from all of these things we're measuring, week, treatment, type. We can use the previous year's treatments to see how much variation we're getting about sort of those averages we're seeing. So we use that in a statistical program called R. I don't know, we specify a non-structured or unstructured covariance matrix. Could go down the rabbit hole if you want to, but essentially, we use a mixed model. It's pretty typical for this kind of design. The design is considered a repeated measures design, where we're going to the same location and doing measurements repeated over the course of a longitudinal study. And in particular, the data presented here was in a simplified version, but in most cases, we have to perform a number of transforms in order to wrangle.
Yeah, definitely. Cool. And then in a kind of fun engineering question, touching back on the crossing between the sand, someone was kind of curious how feasible might it be to block them or put a wall or a fence to but both probably from an experimental and an ecological standpoint, being able to prevent them from doing that.
Maxwell, do you want to take that one?
Dan, do you want to? I would say it would be, building things underwater is hard. They foul. The ocean is a brutal place for underwater equipment. I mean, we see this at the Tankers Grid. When we build things, it requires constant maintenance. So I would say, like, you could try, but there's also nothing preventing urchins from recruiting onto the reefs themselves as larvae. So there's only so much you can block, I guess, if that makes sense.
Yeah, like you could do that as part of the experiment, right? If you had these small plots, I think it would be a lot of work. But and then also, like, well, let's say you do wall off these plots and do this experiment and get your results. Well, shoot, is that really applicable to the real world where there aren't walls, Like, so anyways. Yeah.
And then I think many of us probably, if we've seen urchins getting ripped up in crazy conditions too, and seeing them like little tumbleweed balls that even in the water column sometimes. But cool. And then one of the last question that I have on here, there might be a few more that have been posted recently in the chat, but someone was curious. So we've talked a little bit about how smashing can impact, or in this case, not impact, like, gamete release of urchins. But are there any other, like, detrimental aspects to urchin culling that we might not have talked about yet today?
Yeah, for sure. And that's a really good question. And it is one of, like, the key questions that they're looking at, or that we're looking at with Tankers Reef in particular. I think the biggest concern with Tankers Reef is that the actual rock is very, very soft. It's like chocolate bar. And so there's concern. And I know, just working down there, like installing the grid and everything, I've broken off bits of it. But that said, that is not a question that Reef Check in particular is looking at. We're kind of doing this study as a partnership with NOAA, the National Marine Sanctuary, Department of Fish and Wildlife, and those two entities are doing a much bigger, impact study. That said, other than damage to the actual substrate, I don't think there's a whole lot of other
great
concerns.
To hear.
Yeah.
Fantastic. And then so someone was talking about how important it is for when we have ecological problems to get a head start and start early on trying to fix them. So they were curious if these efforts might be able to jumpstart other areas like Point Lobos or other areas, or in the Monterey region.
Yeah, by jumpstart, you mean, like, we've been at this for three years.
Yeah, that's what I meant to say. I'm sorry.
Yeah, no, but I mean, like, it's, like when we started Lovers 3, when we started that project, it was really because nobody was doing this work, and there was a lot of opposition to it and a lot of skepticism to it. And I think Keith can definitely talk to that. And over the years, I mean, things have come around, and I think I think Tankers happened because of Lovers, because we did that experiment. And even though we didn't have terrific results, where, like, oh, well, look, we went out and got rid of urchins and kelp popped up everywhere, still, just the fact that we could organize and recreational divers could do this work really opened the door for the Tankers project. And the Tankers project was a little bit of a compromise. Like I know Keith will tell you, it's never his first choice. It's not the ideal habitat, and there is a lot of interest in doing this work on granite in areas that do traditionally have more kelp. But I think the department and the management agencies, they're being cautious. It's a lot to allow recreational divers or the general public to kill a native species inside of a marine protected area. Like, that's kind of a big ask. And so they want to see how this tankers projects go. So I mean, I think you can think of these things a little bit as linear and stepping stones. And if the work goes well at tankers, especially if there's a big kelp response at tankers, I think you can make a really good argument for doing this work elsewhere. Point Lobos, it's going to be a tough one. I know these marine protected areas, and Lobos is kind of like the biggest, or the most important marine protected area, the oldest marine protected area in the Monterey area. So I think it'd be hard. But in the conservation areas, I don't know. I didn't think Keith was going to get this far, so who knows?
Yeah. We just had a really interesting question come up from Michael, and Michael is curious, for urchin movement along the reef, do they tend to go from areas of high density to low density, or is it more of just a random movement behavior for them?
I definitely have thoughts on this. Maxwell, do you want to go or?
No, let's share.
It's not random, but it's also very bizarre. Like you will see them move shallower a lot. I think there tends to be more drift algae in shallow, and so you'll see that pretty commonly, where there'll be a barren in shallow, and then it'll be kelp out deep. In fact, Josh Smith even showed that there was a barren out deeper, and they moved shallower, and kelp returned out deep. But other than that, I mean, there's other sites that are the reversed, where it's kelp in shallow and urchins out deep. I guess, like, yeah, they definitely move. They're definitely doing something that's definitely organized. I mean, I'm sure there's a random element to it, but like, I just always, I often when you're down there swimming around, you're like, why is that area a barren and that area not? And what you'll see in that video, like places like that video I showed, where there's a real distinct line, is basically the urchins either hit the kelp and then they switch to that passive feeding because they're being fed, or there's something about the topography there where drift kelp kind of collects on the margin. So those urchins that are on the border just tend to be happy, and as long as they stay happy, then they stay. Why urchins don't move more at tankers than they do, why they moved at lovers more than tankers, or I don't know. When you're there and you have your lanes and you have your rope and you like clear urchins up to the line, and on the other side of the line there's like a ton of urchins, and there doesn't seem to really be anything to stop them, and they don't flood in. I don't know why that is.
Yeah. And then one last one here. They were curious about the possibility of maybe moving urchins, when they're in their active feeding state and they're all out together. Someone was wondering what it might look like to just literally collect them and relocate them to other places. Is that something that has been thought about?
No, not so much. I know they've relocated them up, or like relocated them just on land, just remove them. Like that's what we're doing up at the Noyo project. I think there's other spots where they've taken them offshore and just dumped them, but it's not like, I don't think you'd want to take a bunch of starving urchins to like a place with a lot of kelp and like a healthy kelp forest and just dump them in there, right? One of the things we'll be looking at next year is the effectiveness of removing, of collecting the urchins, putting them in bags and bringing them on shore, versus smashing. So that's one of the things.
Yeah, and I can sort of add to this a little bit in that I know that there are efforts to remove urchins and take them to aquaculture facilities and find perhaps different feeds that can help restore their gonad tissue and make them commercially viable for us to eat. And so that's another option as well. Like Urchinomics is a company that does a lot of work with that.
Yep.
So I think that might be what the more common practice, instead of relocating them to another reef, if you are going to pick them up and move them.
Yeah, for sure.
Cool. So I think that's everything. If I missed your question, I apologize, but feel free to ask away here. We want to make sure that everyone gets to ask what they would like.
Yeah, I've just a quick question. I saw in the paper that there's some interest in the commercial cultivation of kelp for like cattle feed and cosmetics and things like that. Would there be any way to get that encouraged, and then we could monitor the effect of how that works? Are we looking at that at all?
That's not something that we've been looking at directly, but I mean, I know they've done commercial kelp operations in the past. It was big, kind of like around World War II for potash. So it's definitely something that they've done. In Japan, they do, bull kelp aquaculture, like they know how to do it. I know up in Washington, they have a restoration project where they are growing bull kelp on line, basically. Like that's how they do it. They suspend line from the bottom. So I mean, those things are definitely possible. I know there's been talk of growing kelp to feed urchins too. If you grow it and feed them and switch them to that passive feeding mode, like that's an idea that's been floated in particular by Zachary Randall. So anyways, that like there's definitely possibilities there.
Cool. And so Keith said that there is a moratorium on aquaculture permits in California for right now.
All right.
Well, awesome. Thank
Yeah.
you, Maxwell and Dan, so much for sharing this with us, but also the incredible work that you and your team do. It's incredible to be able to see the results, especially after 3 years of blood, sweat, and tears, I'm sure. So thank you for sharing this, and thank you for all of you for coming out with us tonight and hearing what Reef Check and many of you have been doing. We're so excited to share the results with you all. And let me pull up the date for the next seminar. It's going to be the second Wednesday of the month. That's our reoccurring schedule, and so that means it's going to be the February 9th, and that will be about kelp restoration in Mendocino. So staying on the kelp restoration theme, and we're excited to hear what Ian and Morgan and their folks have been doing up there. So you won't want to miss that. We'll see you all there, and thank you everybody for your time.
Awesome.
Yeah, thank you so much, everybody. It was great.
Thank you. Thank you for coming. You guys take care. Have yourself a wonderful new year.